Welcome to my channel. Welcome to this video where I want to express a single fraction into its partial fractions. Partial fractions means I'm going to split this fraction into two fractions. The method that I'm going to use assumes that this fraction is a proper fraction, and I'm going to explain what a proper fraction is. In normal arithmetic fractions, if I have a fraction like 2 over 3, this fraction is proper in the sense that 2 is less than 3. The numerator is smaller than the denominator. Then that fraction is said to be a proper fraction. If I have 7 over 2, for instance, this is improper in the sense that the denominator is now bigger than the numerator. Sorry, the numerator is now bigger than the denominator. So, proper, numerator smaller than denominator. Improper, numerator greater than the denominator. So, as far as algebraic fractions are concerned, we check with the degree of an expression. This numerator here is 11 minus 3x. X has got an exponent of 1. So, the degree of this expression is 1. But let's check the degree of the expression in the denominator. If I multiply this out, the first by the first will give me x squared. So the degree of the denominator is 2, while the degree of the numerator is 1. In algebra, we call this a proper fraction as well. So I'm going to suggest this method. Split this fraction 11 minus 3x over x minus 1 brackets x plus 3 into two fractions. One of them, let's call it capital A over x minus 1 plus b over x plus 3. So I'm going to use this factor and this one as two independent factors of the fraction that I want to split into. So let us simplify the right-hand side. This one, I'm going to maintain it as it is. X plus 3 is equal to. Here, the LCD of the fraction is x minus 1, x plus 3. This is the lowest common denominator, which is just a product of the two factors there. Now, when we simplify this, we divide x minus 1 into that entire factor there. Then multiply by that. So we get a open x plus 3. We are saying x minus 1 will cancel with this x minus 1. Plus, similarly, b times x minus 1. Because if I say x plus 3 into that, I remain with x minus 1, by which I multiply b. Right. So we can see that this denominator on the left equals that denominator on the right. But these two fractions are equal. That implies that the numerators themselves must be equal. So I'm going to have 11 minus 3x is equal to a open x plus 3 plus b open x minus 1. Okay. How I am going to eliminate either a or b is very simple. I am going to let x equal to 1. If I let x equal to 1, I am going to have 1 minus 1 in this bracket. And 1 minus 1 is 0. So I am sure that this part will fall off when x is 1. Anything multiplied by 0 will be 0. So let x equal to 1. I'm going to substitute x equal to 1 in the entire expression. On the left, x equal to 1 will give me 11 minus 3, which is 8, is equal to. If x is 1 here, this becomes 1 plus 3, which is 4, so I'm going to have 4a. If x is 1, this falls off because 1 minus 1 is 0 times b is 0. So 8 is equal to 4a, which implies that a is equal to 2 if I divide both sides by 4. Similarly, I'm going to let x equal to negative 3. Why negative 3? Because I know the additive inverse of 3 is negative 3, because negative 3 plus 3 will give me 0. So if I let x equal to negative 3, substituting it on the right, I'm going to have 11 minus 3 times negative 3. And that gives us 11 plus 9, which is 20, is equal to. If I let x equal to negative 3, like I illustrated, this falls off. But a negative 3 here will be negative 3 minus 1, which is negative 4 times b, which is negative 4b, which implies that your b is going to be equal to negative 5. Your b is equal to negative 5. That means I have managed to get the value of a and the value of b. What is left now is just to simplify that, to substitute back into that and create the two fractions. So this is going to be, my a is 2, so it's 2 over x minus 1. My b is negative 5. So here I'm going to ignore this and put negative 5. So it's minus 5 over x plus 3. These are the two fractions that represent that composite fraction. This is what we mean by partial fractions. Thank you so much.